Hi everyone. Thank you for your smile. I'm going to talk about the tools for embedded software. Then first, I introduce myself briefly. I'm Ryoma Kawajiri from the robot team. I have interested in machine learning, reinforcement learning, IoT. And I have joined PFN the last year, June. Then I have been experienced for the IoT development or research. So I want to talk about such a kind of things. Then, so as you know, the era of the IoT or edge-heavy computing coming. So we are the company for it. Then the embedded software, such as for the cars or robotics or such things, becoming the important. So what is embedded software? According to Wikipedia, computer software written to control machines or devices that are not typically thought of as computers. It is typically specialized for particular hardware that it runs on and has time and memory constraints. So there are many constraints such as memories, computation, power consumption, and networks, etc. So there are difficulties for the development of embedded softwares. So first, it is hard to build development environment. Some of you may experience here, then stop to try to develop. Then even if you remember how to develop, the develop tools can be vary for the hardware platform, and so it means there are very few practices for the embedded programming, unlike server-side or mobile apps. Then I want to introduce two tools for it helps a bit. It helps a bit better. One is called PlatformIO. That is for the microcontroller MCU, such as the Arduino or ARM embedded. And the second one is resinOS. That is for embedded Linux, such as Raspberry Pi or such Beagle and Bones. Then first, I want to talk about the PlatformIO. So the main problem for the MCU is there are, as I mentioned, multiple hardware platforms require different tools, and it's difficult to proper library or code sampling, and it is difficult to share the projects between teams. And there are many types of boards and different types of the project settings and so on. So the PlatformIO is a system to solve such problems. It includes a package library manager, and they provide the same command line interaction for every platforms, and it can be used for continuous integration or IDEs, and it is compatible with the very popular framework Arduino or ARM embedded. Then I want to show you how it is easy to build the project. So I bring Arduino here. Here is the empty directory for the project. Then I want to initialize the project by PlatformIO. This is the command, and dual USB is the board name. Then it makes some files. Then this file is the configuration. Then here's the name of the board. Then I want to create some main file. So if you are familiar with the Arduino, this is the basic command. Then to build it, the code is do nothing, but just test for building. Then it start to build and to upload the image to the board. Similarly, it's success, but it don't work. Do nothing, so you may suspicious it works. So I'm gonna say blink. This is the simplest code for blinking the LED. Then upload again. Build the code. Then upload. Can see? Yeah, it's blinking slowly. Then I want to show you how to use the libraries. So So you can search the libraries from the web interface. You can here. I want to install RTOS. That is the famous real-time OS. You can see the example codes and other information such as the compatibility of frameworks. And if you decide to install, you can see there's some instructions to how to install. I want to use the configuration file, so I copy the version and names here. Then I open the configuration file, then just write down the steps like this. Then click on upload again. It's downloading the library and build again, but I forgot to change the source code, so it don't use it. Then I rewrite the code. code. This is the code using the free RTOS, but almost same with the previous one. They're just blinking LED with different frequency. Then upload again. They're blinking more faster than before. Yeah. So you can use the library easily. So as well. Okay. Then go to presentation. Next, I want to explain about the resinOS. That is Docker for embedded programming. So the resin, there are cloud service called resinIO. That is for the continuous integration or development or monitoring service for embedded programming. Then resinOS was developed by the service. Then this is the OS tailored for the containers and networking. So IoT applications. So you can write application within the Docker container. Then there are some minimum configurations for the utility, the networking or containerizing. So everything the CPUs. So why resinOS? So you can use the modern workflows powered by the Docker framework, and Resin already supports many boards such as the Raspberry Pi, as you know, and there are also the Intel NUC or Jetson as well, and it is also open source and actively developed currently. Okay, so the demo again. So I wanna show you the development. This is a web server running on the resinOS, on the Raspberry Pi on my desk. Then this is the project file for it. Then the difference is just is the Docker file. The base image of the Docker image is just from the resin images. The images built for the Raspberry Pi. Then the rest of the lines are as usual Docker file. And then others are just web server code by using Node. Then this is the code. Then so to show that it can be deployed easily, I will change the code like this. Then deploy it again. And syncing the code and stopping current application. They're restarting the code. And I reload it. The phrase can be changed. Then, but it can. By this example, you cannot see the Docker is working. So I'm gonna change the Docker file as well. So if I change the Docker file like this is meaningless. But if I change it, the Docker image will be rebuilt by detecting the changes like this. And restarting the application. Yeah, and restarting success. So that's all for my presentation demo. And if you're interested in these tools, you can see the more detailed documentations and presentations. Thank you very much. Quick questions.
Have you done transfer to from a chainer trained model to doing inference on a embedded software?
I have not yet tried. Yeah, tried, but I've heard the Ryoma and Miyashita-san project run the inference on the Raspberry Pi, but so I wanted it may be the good example for it using resinOS.
Okay, thanks.
Any questions? Okay, thank you very much.